All right, here's some solutions from our quiz last week. We start off with number one, who was just a mess, really, right from B on. In B, remember, we had a little typo here. That should have actually been 0 and -3. Tried to catch that. The bigger problem, I guess, was this one here, where that line just isn't a tangent to this curve. And there was no, it wasn't even close. It wasn't like it was -1/4 or anything like that. So something was wrong with that one. But so we just actually ended up scrapping that part of the quiz there. It was good that a lot of you noticed, and I mean that's maybe the benefit of that. And I'll try not to do it again, but most people did notice that there were some mistakes there. Okay, but let's get started. A, best part of this question, and most people doing this very well, was finding the derivative using implicit differentiation. So we're finding the derivative of y with respect to x. So anytime that we had something that didn't have an x value in there, remember we have to put that dy dx. So the derivative of y squared is 2y, but then we need that dy dx. Minus the derivative of x is 1. The derivative of 2y is 2, but then we need that dy dx. And the derivative of 3 is 0, and the derivative of 0 is 0. So we can just finish that off with equals 0. Now it's just a matter of rearranging this a little bit. I'm going to move the 1 to this side, and that's going to give me the 1. And then keep all my dy's together, but I can factor out that dy dx. And we get 2y plus 2, and we divide that off. 2y plus 2 is equal to dy dx. And that was part A. From then on, part B, and I just want to see if I can take this. Okay, I'm just going to get rid of all that writing that we did. Okay, so from then on, part B was where we really started to mess up. So the first part here, we had to change that to a -3. But then we want the tangent line to the curve, so it's not too bad. Remember, to find the tangent line, we need slope. Well, we just had the equation for slope. Looks like this. And if we put in actually -3, we get plus 2. And that becomes 1/4. And then we can go ahead and find our point, and remember our point was in fact the 0 and the -3, and now it becomes y minus 3 minus -3 is 1/4, and this is x minus 0. So in fact it was really close to this second equation here for some reason, but this becomes 1/4, and then we move this over -3. That's what we should have had after we made our adjustment for part B. Part C, just kind of all wrong here. So I want to show you just what we could do. Get rid of this stuff again. The idea here, again, was if this is the curve, find point P. And it's a good question, and I will give you one that actually works out as an example, not as part of a quiz, but as an example, so we can see what it's actually supposed to look like here. But this is the slope of our line, of our tangent line. And remember, slope was 1/2y plus 2. So using that equation, we can figure out what y is. Okay, so if we do that, y actually becomes 1. Now we need to figure out what the x value is at 1. Well, this is where this started to mess up here a little bit, because if we go back to the original function and I put in y equal to 1, I get y 1 squared, 1 squared minus x plus 2 times 1 minus 3 equals 0. And we end up with 1 plus 2, that is 3, and minus x minus 3 equals 0. That cancels off, and it looks like maybe x equal to 0. And x is 0, y is 1. Okay, and that is actually a point that is on the curve. 0 and 1 is on the curve. But the problem is, if it's on the curve and we have a tangent line, then it should be on the tangent line as well, right? So if we think of this curve as actually a sideways parabola, it does something like this. And if x equal to 0 is on the curve, or I'm just going to kind of make something up here. So, all right, so if x equal to 0 is on the curve, then the point should also be on the tangent line. So 0 and 1 is on the curve. 0 and 1 should also be part of this here, and it doesn't, right? If you put in y equal to 1 into the tangent line, and this is what one of the students said, is they should be both on the same line. Well, if I solve this, kind of move this over, that becomes negative 2 is 1/4 x. Now we get x is negative 8. And so you can see that they're not the same. They're taking us to two different points for p, and it just didn't work. So we scrapped that part of the quiz there. Okay, let's take a look at the second question. So here was the second question that we had, and we were given this function f defined as f of x equals the integral from 0 to x of gt dt. Now that is really just a fancy way of telling us that if we take the derivative of both sides, the derivative of f is f of f prime x, the derivative of the integral just becomes like g of x. So it's basically saying that g of x is the derivative of f. And then what they do in the question is they give us the graph of g. So they've given us the graph of f prime. So they will do that. I know it's a little tricky, but they're really just telling us the graph that we have is f prime. Now, in the question, though, we want to find f of negative 3, f of positive 3. We're going to find all the values on x such that f of x is a relative minimum or maximum, and we're going to find the values where we have a point of inflection. So when we look at part A, we want to find f of negative 3. So according to our defined f of x, f of negative 3 is going to equal the integral from 0 to negative 3 of gt dt. All right, so first, and a lot of people did notice this, it was a 0 and a negative. Well, that'd be like going backwards. So we actually have to flip that over. One of our first integral rules said that if I flip those boundary points over and start negative 3 to 0, then I get the opposite of what I had, gt dt. Now, all this is saying then is the area under the curve from negative 3 to 0. So we need that curve, that area all the way. And then we're going to take the opposite of that. And that's going to be f of negative 3. So let's go ahead and look at our curve. I just want to erase some of this stuff so we can draw on there. This is 2 times negative 2. remember, we're below the axis, so 2 times 2 is 4. We take half of that for the rectangle. That would be 2. This is negative 2 for this area. We have 1 times 2, and that is 2. Half is 1, and it's above the x-axis. So we have negative 2 and 1. That becomes negative 1, but we're going to take the opposite of that, and that is going to be 1. Well, let's keep going and see if we can find f of 3. First of all, let's get rid of all of that then. So I want f of 3, and we're going to set that up the same way. That becomes the integral from 0 to 3 of gt dt. So it actually kind of looks like the fundamental theorem, but it's not quite really. But this is the area under g, or f prime, from 0 to 3. So we want all of that area. Okay, so let's go ahead and do the work there. This first triangle, there's 2. This is 1. 2 times 1, half of that. That triangle is 1. This has a base of 2 and a height of 1. So base times height is 2 divided by 2 is 1. We get that's a negative 1 because it's below. So we have a 1 and a negative 1. This whole thing is 0. So f of negative 3 was 1. F of 3 is 0. Okay, let's go on to part 2. We want to find all the values where we have a minimum or a maximum. So again, let's get rid of a bunch of that stuff we don't need. Let's find minimums and maximums. So what we can do, and what we've tried to do a lot of times, is sketch this little grid out. So I'm going to go f prime and f. I can find out where we have minimums. Now this is where this comes in, that g is actually f prime, because we can see a 0 here at negative 1. We can see another 0 here at 1, and another 0 out here at 3. And we want to test these here. I'm going to just put in negative 3 because it's over this interval negative 3 to 3. So let's try negative 2. If I'm at negative 2, my derivative is a negative value, and we are going down. Between negative 1 and 1, all my values are positive, and we are increasing. From 1 to 3, all my values are negative, and we're decreasing. So we should have a minimum value at negative 1, and we're going to have a relative maximum value at positive 1. We're not sure 3, what is happening after 3. So those are the only 2 points between the negative 3 and the 3 where we have relative maximums or minimums. Now we could also do this verbally, just looking. We don't need the chart. We don't have to have the chart. We could do it verbally, and we'd have to write it out, but we can say our function, our derivative, goes from negative to positive at negative 1. So when it goes from negative to positive, that is a relative minimum. Relative min at x equal to negative 1, because the graph of f inverse goes from negative to positive. And I'm abbreviating there a little bit, but we would write that out. We could do the same thing for positive 1, but we would have to say it's a maximum at x equal to positive 1 because the graph goes from positive to negative. So you could write that out. You could show your grid with your work there as well. Find all the values where f of x has a point of inflection. So we want all the values where f of x has a point of inflection. Well, this is where I do really like working with the grid, because we can just extend that now. There was f prime, there was f double prime. So we know if the second derivative goes from positive and negative. So we had our -3, there was our +3 out here. We're going to add a couple more points here. Now we really want those maximums and minimums, and we have some maximums and minimums here. So when the derivatives are at maximum and minimums, that's when we should have points of inflection. So all we're going to do is test those. So we're going to test our 1, and we're going to test our, we're going to test our 0, and we're going to test our 2. So in this interval here, our derivative is increasing. So as we go, it's increasing all the way here up to 0. So that means its derivative would have been positive, and going all the way back, this would have been concave up. From 0 all the way to 2, we are decreasing. Our derivative, f prime, is decreasing, so that's negative, and 2 steps back, that is concave down. From 2 to 3, we are increasing, and that would be concave up. So in fact, we have points of inflection at both x equal to 0 and x equal to 2. And that one we'd finished off. So your justification is the picture that you've drawn here, or you could basically write it out again and say we get points of inflection where the derivative has maximum and minimum values. Okay, I'll keep posting some more, and probably on Thursday this week I'm going to throw one more question at you. Okay, they're just a little hard to mark, so when you just send them in, so we'll figure something else. All right, take care.